Union is also example for user-defined data type. With the help of dot operator, I can able to access the members which is stored or present in the union. The size of the structure is always sum of every data member during memory allocation in structure. For each data members, the compiler is going to allocate the memory. Hello to all, a warm welcome to my new session on programming in C, and the topic name here is Union. I'm Revati from the Department of Computer Science, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. So dear student, before going to start my today's session, let's recall the topics which I have covered in my last session. Dear student, I started with structure. So what is structure? That's an example for user-defined data type. Along with that, I have discussed how to create structure, how to initialize structure, how to access structure. Along with that, I have discussed array of structure as well as nested structure. But in my today's session, once again, I'm going to deal with union. So dear student, here union is also example for user-defined data type. Along with that, I'm going to deal with how to define a union example. Along with that, how to access union members as well as the difference between structure and union. These are the topics I'm going to deal in my today's session. So dear student, at the beginning, I'm going to have union. So what is this union? I hope all are familiar with the word union. So dear student, listen here that union is also example for user-defined data type. That means user can able to define their own data type by using predefined data type. That means whatever the members I'm going to define in my data type that may have same data type or different data type, but still union is example for user-defined data type. So here union can be defined as a user-defined data type which holds a collection of different variables. So here variable is nothing but predefined different variable or same kind of variables, but it's going to use same memory location. I repeat, it is a collection of different variables of different data types. I'm going to have different variables, along with that different data types, but it's going to use same memory location. So it's going to use same memory location. The union can also be defined as many members, but only one member can contain a value at a particular point of time. So here union can also use to define many members, but only one member can able to have particular point of time. So union is a user-defined data type. So here union is a user-defined data type, but if I consider structure, it's going to share the same memory location. That means it's going to share the same memory location. But if I consider union, it's going to use particular memory location. Now see here, I'm going to have union like structure. I'm going to have union keyword. Along with that, I'm going to have union tag. That is nothing but union name, then I'm going to have data members or member definition, and I can able to create union variables. So I can able to create one or more union variables. At the same time, I'm going to have the example here, that is union, and my union type is data. In that, I'm going to have integer data type, float data type, as well as character data type. And the union variable name here is data. Now, dear student, let's see the memory allocation for this union data. Now, the compiler is responsible for allocating the memory location. Now, dear student, what is my first data? It is integer, 2 byte. And if I consider float, it is 4 byte. And if I go with character, that is 20 byte. That means the size of the character is 1 byte. But here I have array of character, size is 20. 20 into 1, it is 20 byte. Now, the compiler is responsible for allocating the memory, and it's going to allocate 20 byte of memory. So it's going to allocate only 20 byte of memory. That means while allocating memory for union, the compiler is going to consider only the largest memory. It's going to focus only the largest memory. And which is the largest memory among all three memory location? That is 20 byte. So here compiler is going to reserve 20 bytes for this union. Now, dear student, I'm going to have the example here. So I'm going to have union, and here union name is data, and I'm going to have the members, that is I, float, first one integer, second one float, then I'm going to have character. And what is the size of character? It is 20 byte. Now I'm going to write the main program, and I'm going to create the variable, that is union variable. And what's the union variable name? That is data. So dear student, here also I can able to create union variables in two ways. One is with my union definition itself, I can able to create the variable, or within my main program, I can able to create union variable name. Suppose if I'm going to create union variable name within the main program, then first I want to write the union keyword. Along with that, I want to specify the union name. Along with that, I want to specify the union variable name. Now I'm going to print the value, that is memory size occupied by data. So what is the memory size occupied by the union name data? It is 20 byte. So I'm going to get the output that it is 20 byte. Now, dear student, how can I access union members? So dear student, with the help of union variable dot data member, that means to access members which is present in the union, I want dot operator. That means with the help of dot operator, I can able to access the members which is stored or present in the union. Similar to structure, that means first I want to use union variable name, that is data dot, and I'm going to use I. So I is nothing but the data member which is present in union. The next one, data dot F, and the last one, it is string. So data dot str. So this is the way I can able to access union members. Now dear student, I'm going to have the difference between structure as well as union. So dear student, to create structure, I'm going to use struct keyword, and if I want to create union, I'm going to use union keyword. And if I go with structure, every members within structure is assigned a unique memory location. That means during memory allocation in structure, for each data members, the compiler is going to allocate the memory. But if I consider union, a memory location is shared by all the data members. That means the compiler is going to consider only the largest memory location, and all the members are going to share same memory location, that is in union. Now under structure, the third difference here is changing the values of one data member will not affect other structure member. That means if I modify the values of one data member in a structure, that does not affect other data members, because each data members are going to use different memory location. But if I consider union, if I make any changes in one data member, then it's going to reflect in other data member, because all the data members are going to use or share same memory. The last difference here is it enables you to initialize several members at once. That means by using structure, I can able to initialize several members at a time. But if I go with union, it's possible to initialize only one member at a time, because in union, the same memory location is shared between all the members. For that reason, only one member can able to initialize at a time. That means union enables us to initialize only the first member of function. So these are the difference between structure as well as union. Further, I'm going to have the total size of the structure is sum of size of every data. So here the size of the structure is always sum of every data member. But if I consider union, the total size of the union is always greatest data members. That is nothing but the size of greatest data members. And if I consider structure, it is mainly used for storing various data types. That means here structures are mainly used to store various data types. Whereas if I consider union, it is mainly used to store one of the many data types. So one of the many data types that are available. And if I consider structure, it occupies space for each and every members. So it's going to occupy space for each and every members. But if I go with union, it occupies space for a member. That means in union, I'm going to consider only the largest data size. So it occupies space for a member that is going to have highest size. So largest data size I'm going to consider in union. Now, if I consider structure, you can retrieve any member at a time. That means I can able to retrieve any members at a time in structure. But if I go with union, you can access one member. That means I can able to access only one member at a time, because the memory is shared between all the data members. For that reason, I can able to access only one member at a time. And if I consider structure, I can able to create array of structure. So here it supports flexible array. But if I go with union, I cannot able to create array of union because it does not support a flexible array. So these are the some of the difference between structure as well as union. Anyway, dear student, this is the last topic of this subject, that is nothing but C programming. That means this is the last topic of C programming. So dear student, thank you for constant support as well as encouragement. Keep studying and keep watching. Thank you.